Hello everyone, welcome to Computer Science Hub. Today's topic is the number conversion of a decimal number. So in our previous video, we have discussed about the number system. We have discussed what is a number system, what is meant by the base of a number system, and about different number systems like decimal, octal, hexadecimal, and binary. We have discussed the base of each number system, what is the meaning of that number system, and the symbols used in that number system, etc. Okay, so now it's time to convert one number system into other number system. So it is possible to convert any number system into any other number system. We can convert a binary into decimal, a decimal into hexadecimal, a hexadecimal into octal, and so on. So I am dividing these conversions into three major areas. First, we are going to convert a decimal number into all the three other forms, that is a decimal to binary, octal, and hexadecimal. Next, we are going to convert all the three forms into decimal, that is a binary, octal, hexa are converted into decimal. Next category is the conversion of a binary number into octal and hexa, a hexa and octal into binary, and of course from hexa to octa and vice versa. Okay, these are the major categories. So all these categories are similar. These major categories are having similar methods. So first category is the conversion of a decimal number. In this video, we are discussing how to convert a decimal number into a binary, an octal, or to a hexadecimal number. Okay, so let's start with the decimal to binary conversion. So we are going to convert a decimal number into a binary number. The method of converting a decimal number to binary number is by repeated division. So the method we are using is the repeated division. So in this number, a decimal number is successively divided by 2 and the reminders are recorded. The binary equivalent is obtained by grouping all the reminders with the last reminder being the most significant bit and first reminder being the least significant bit. So the binary equivalent is obtained by successively dividing the decimal number by 2 and recording the reminders. And these reminders are recorded in reverse order. Okay. In all these cases, the reminders will be either 0 or 1. So we are dividing a decimal number by 2. So all the reminders will be a number that is less than 2. That means either 0 or 1. This is the method to convert a decimal number into a binary number. Let's consider an example. So here we are converting a decimal number into a binary number. So let's look. Our decimal number is 25 and first step is to divide the decimal number by 2. 25 by 2, we will get 12 as the answer and 1 will be the remainder. So record this remainder. Then this 12 is again divided by 2. So 12 is divided by 2, we get 6 as the answer. 6 into 2 is equal to 12, which means the 0 is the remainder. Then this 6 is again divided by 2. 6 divided by 2 means 3 is the answer and remainder will be 0. This 3 is again divided by 2. So 1 is the answer and remainder will be 1. Then this 1 is divided by 2, we will get 0 as the answer and 1 as the remainder. So remember, we have to do this repeated division until we get a 0 over here. Then these reminders are recorded in the reverse order from bottom to top. The last reminder will be the most significant bit. The first reminder will be the least significant bit. So let's look 11001. This is the answer of converting a decimal number. A decimal 25 is equivalent to 11001 in binary. And don't forget to write this 2 over here. That is the base of binary number system. Only the decimal number system can be written as such, like 25, like 80. Okay, it's not compulsory to record the base over decimal number system, but for other number systems we have to write the base to denote that number system is in that particular type, that is here. By recording 2, we know that this is a binary number. Next, consider the next example. We are going to convert this decimal number 80 into binary. So the conversions are like this. 80. 80 is divided by 2. So first step, 80 divided by 2, we get 40 as the answer, right? 40. And remainder is 0. Next, this 40 is again divided by 2. 40 divided by 2, we will get 20 is the answer, and again remainder is 0. Next, 20 is again divided by 2. We get 10 is the answer, and again remainder is 0. This 10 is again divided by 2. We get 5 is the answer, and the remainder is 0. This 5 is divided by 2. We get 2 is the answer, but the remainder is 1. Again, this 2 is divided by 2. We get 0 is the answer. 1. 1 is the answer and 0 is the remainder. Again, this 1 is divided by 2. We get 0 is the answer and 1 is the remainder. And this is shown over here. So, record these reminders in the reverse order from last to first. So, our answer is 1 0 1 0 0 0 0. Okay. The decimal number 80 is equivalent to 1010000 to the base 2. This is the conversion. And note a point here, that is a binary equivalent of odd decimal number ends with 1 and even decimal number ends with 0. If we take a binary number, if we take a odd decimal number, its binary equivalent will be having 1 at the end. If we take an even decimal number like 80, its binary equivalent will be having a 0 at the end. That's a simple point to note. Okay, this is a made 6 steps of conversion. So a decimal number is repeatedly divided by 2 and recording the reminders, and these reminders are arranged in the reverse order. We will get equivalent binary number. Let's move on to next topic, converting a decimal fraction to binary. So a decimal fraction number is converted to binary. To convert this fraction, we use the method of repeated multiplication by 2. So to convert a normal decimal number, we are using repeated division by 2. To convert a fraction, we are repeatedly multiplying the number and multiplying using the base 2. At first, the decimal fraction is multiplied by 2. The integer part of the answer will be the MSB of binary fraction. At first, we are going to multiply that decimal fractional number by 2, and we will get an integer part and a fractional part. So we are going to record the integer part, and we are going to multiply this fractional part again by 2, and to obtain the next significant bit of the binary fraction. This procedure is continued till the fractional part product is 0 or a desired precision is obtained. Let's consider this example. We are going to convert the number 0.75 into a binary number. So 0.75, we are doing repeated multiplication. So 0.75 is multiplied by 2. When multiplies, we will be getting 1.50 as answer. In this 1.50, 1 is the integer part and 0.50 is the fractional part. So record the integer part 1 over here, and again multiply this fractional part by 2. 0.50 into 2 is equal to 1. Again here the integer part is 1, record the integer part, and fractional part is 0, 0.00. So that is the end, that is until we get 0 in the fractional part, we have to do this multiplication process. Okay, so we have to do this multiplication until we get 0 at the fractional part or the desired precision is achieved. That is, in the question, it may specify do this conversion up to 4 decimal places, up to 3 decimal places, etc. So when we reach the desired precision, we can stop, or up to when we get the 0 over the fractional part. So consider the next example, convert 0.625 to binary. So this 0.625 is divided by 2. When we divide, we will get 1.25 as answer. In the 1.25, 1 is the integer part, 0.25 is the fractional part. Record the integer part here, 1 over here, and multiply the fractional part 0.25 again by 2. When 0.25 is multiplied by 2, we will get 0.50 as the answer. Here also integer part is 0, fractional part is 0.50. So record the integer part. Then fractional part 0.50 is again multiplied by 2. We will get 1 as the answer. Okay, 1.00. Record 1 over here and the fractional part is 0. So we can stop here. And record this integer part is recorded in this manner. So 0.625 binary equal to 0.625 decimal number equal to 0.101 in binary. And remember to denote this base as 2. Next question, convert 15.25 to binary. So here the integer part is 15 and fractional part is 0.25. Here we have to apply both methods, that is repeated division and repeated multiplication. First consider the integer whole number 15. Then convert this into binary by repeated division. Next consider the fractional number 0.25. Convert this 0.25 into binary by doing the repeated multiplication method. Okay. So first this 15 is divided by 2. The 15 is considered and the 15 is divided by 2. That means we are doing repeated division techniques. So this 15 is divided by 2. We will get 7 is the answer. 7 into 2 is equal to 14. So remainder is 1. Then 7 is again divided by 2. We will get 3. 3 into 2 is 6. 1 is the remainder. This 3 is again divided by 2. We will get 1 is the answer. 1 is the remainder. 1 is divided by 2, we will get 0 is the answer and 1 is the remainder. Record this remainder in the reverse order. And this is same when we record it in reverse or forward. But remember we have to record in the reverse order. 1, 1, 1, 1 is the answer. So the 15 integer part is over. Next consider the fractional part 0.25. Convert this 0.25 to binary. In order to convert a fractional decimal number to binary, we have to use the repeated multiplication by 2. So we are going to repeatedly multiply this 0.25 by 2. 0.25 into 2. We will get 0.50 is the answer. Here 0 is the integer part, 0.50 is the fractional part. Record the integer part. So 0 is recorded and again multiply the fractional part by 2. 0.50 into 2. 0.50 into 2 is equal to 1. Here 1 is the integer part. Record the integer part. The fractional part is 0.00. So when the fractional part reaches 0, we can end the conversion because 0.0 by 0.00 into 2 is again 0. So nothing new happens. So this is the end. Then combine these both answers. 15.25. So in place of 15 we can write 1111. 1111 point. In place of 0.25 we can write 0.01. So 1111.01. This is the answer and this is the method of converting a decimal number to binary number. So the whole decimal number is converted to binary by repeatedly dividing by 2 and the fractional number is converted to binary by repeatedly multiplying by 2. The same method is used in another conversions also. Next we are going to consider decimal to octal conversion. To convert a decimal number into an octal number, we are using repeated division, but not by 2 but by 8 because the base of the octal number is 8. So we are going to repeatedly divide the decimal number by 8. The method of converting a decimal number to octal number is also by repeated division. In this method, the number is successively divided by 8 and the remainders are recorded. So here we are successively dividing the decimal number by 8 and the remainders are recorded. The octal equivalent is obtained by grouping all the remainders with the last remainder being the MST and first remainder being the LST. So the procedure is same as decimal to binary conversion, but here we are dividing by 8 and recording the remainders in the reverse order. And of course we are dividing by 8. So the remainders will be numbers less than 8. That is reminders will be 0, 1, 2, 3, 4, 5, 6, 7. Up to 7. We can get reminders like 0 to 7. Any numbers are possible. This is the method of converting a decimal to octal number. So the number is 125 is the decimal number. We are going to convert this into octal. So first step is to divide it by 8. When we divide 125 by 8, we will get 15 as the answer, 1 5. 15 is the answer and the remainder will be 5. And when we convert this, again divide this 15 by 8, we will get 1 is the answer and 7 as remainder. Then this 1 is again divided by 8. Of course, 0 is the answer and 1 will be the remainder. And record this remainder in the reverse order. So we will get 175 as the answer. 125 to the base 10 is equal to 175 to the base 8. This is same as the decimal to binary conversion. The only difference is the we are dividing using 8. Find the octal equivalent of 400. To convert this 400, first we can divide it by 8. We will get 50 is the answer. 50 into 8 is equal to 400. So remainder is 0. Then again divide 50 by 8. Then 50 by 8 we will get 6 as the fraction, whole number and 2 will be the remainder. Then again divide the 6 by 8. So we will get 0 is the answer and 6 is the remainder. So do this conversion up to we get 0 over here. And record this in the reverse order, that is 620. 400 to the base 10 is equal to 620 to the base 8. Don't forget to mention the base over here. Next, converting a decimal fraction to octal. So to convert a fractional decimal number to octal number, we use the method of repeated multiplication by 8 and recording integer part of result. So the step is similar as decimal conversion. Here instead of repeated division, we are using repeated multiplication and repeated multiplication by the base of octal, that is 8. In decimal to binary, we have repeatedly multiplied using 2 and here we are repeatedly multiplying using 8 and recording the integer part of the result. In that conversion, we were recording the reminders. Here we are recording the integer part of the result. So consider this example. This is a decimal fraction 0.23. We are going to convert this 0.23 into octal number. So the method used is repeated multiplication by 8. 0.23 into 8. 0.23 into 8 is equal to, the answer is 1.84. Here 1 is the integer part, 0.84 is the fractional part. So record this integer part. 1 is recorded and the fractional part is again multiplied by 8. 0.84 is again multiplied by 8 equal to 6.72. In this result, we are having this integer part as 6 and fractional part as 0.72. So integer part 6 is recorded here and the fractional part 0.72 is again multiplied by 8 equal to 5.76 is the answer. Here also integer part is 5 and record this integer part. So here I have done up to 3 precisions. 3 precisions, 0.23 to the base 10 is equal to 0.165 is the answer. Next step is the decimal to hexadecimal conversion. In this method, we are going to convert a decimal number into a hexadecimal number. The method used is also repeated division. Repeated division by the base, that is 16. Repeated division by 16 and we are going to successively divide by 16 and the reminders are recorded and these reminders are collected in the reverse order and of course when we divide by 16 the reminders will be up to 0 to 15. 0 to 9 are integers and up to 10 to 15 we are using these letters A, B, C, D, E, F. This is the example. A decimal number 155 is divided by 16. 155 divided by 16, we will get 9 as the answer and 11 is the remainder. But we cannot write 11 as such, but replace this 11 by the symbol. Symbol is for 10, it is A. For 11, the symbol is B. So 11 is replaced by B. Then this 9 is again divided by 16. We get 0 is the answer and 9 is the remainder. Then record these reminders in reverse order. The method will be 9b. Answer will be 9b. 155 is equal to 9b to the base 16. Next example, 380. 380 is divided by 16. 380 divided by 16, we get 23 is the answer and 12 is the remainder. Then 12 is replaced by C. C is the symbol. Next, again this 23 is divided by 16. We will get 1 is the answer, and 7 is the remainder. This 1 is again divided by 16. We get 0 is the answer, 1 is the remainder. Then what to do next? Next, record these reminders in the reverse order. So the answer is 1, 7, 12. Instead of 12, we have to write C. So 1, 7, C to the base 16. Don't forget to denote this base over here. So 17C is the answer. Then last conversion, converting a decimal fraction to hexadecimal number. The same procedure is used. We are going to repeatedly multiply by the base 16 and record the integer parts. Convert 0.03125 into hexadecimal, 0.03125 into 16 equal to 0.5. In the 0.5, 0 is the integer part and 0.5 is the fractional part. Record the integer part over here. The fractional part is again multiplied by 16. 0.5 into 16 is equal to 8. Here also 8 is the integer part, 0 is the fractional part. Record the integer part, and since the fractional part is 0, we can stop here. So 0.03125 to the base 10 is equal to 0.08 is the answer. Okay, so far we have discussed all the conversions of a decimal number. A decimal number is converted to binary, octal and hexadecimal. Decimal fraction is also converted to this method. So to convert a decimal number, the step we have to do is repeated division by the base of the destination number. In case of fraction, we have to do repeated multiplication by the base of the destination number. Okay, hope the concept is clear. Thank you.